The following content has been provided by RWTH, Aachen University.
Welcome to the iOS lecture. Today it will be very crowded because a lot of people applied, but we will sort this out in the next weeks because we don't have a lot of seats, but I will talk about this now. So my name is Voelker. I'm the deputy head of the chair of media informatics. And I'm teaching this class together with my colleague, Philipp Wacker, who's an assistant here. He's not here today, but he will join us next week. And if you have any questions about the lecture, just drop us an email or ask in Moodle later on. So we teach this class for several years now. I took over it for 3 years, but we started it actually in 2008 or something. And we have a good experience in that. And Philipp and I are actually certified Apple trainers for Swift 4. Swift 5 will be released, but doesn't make any difference so far. So we can talk a little bit about this in detail, and I will show you that. So the class goals is basically to learn how to work with iOS, how to develop applications, how to understand what Swift does, how you can work with Swift, how to use advanced frameworks like Metal, like CoreML and all of these stuff that are currently out there supported by Apple. And so this is the technical side, but we also go into a little bit about how to develop applications that are actually useful, what kind of applications can be used by users, what is the UX and usability of applications, because that's actually the research area of our chair. So we're not typically a software development chair, but we are about user interfaces and how people interact with technology. So in this class, we're fusing the background of iOS development with a little bit of UX design and usability, and we will focus on this in the project part, which I'll talk about later on, about how to develop applications that are actually useful for users and what is the user experience in these cases. As I said, and the most important thing is here in this class, we do a lot of coding. We want to teach you a lot of coding. You will do a seminar where you have to code, and then you have the last part of the lecture will be mostly about a project where you have to develop an application. So it's a very hands-on class, very untypical for this computer science department, but at the end, you're a computer scientist, you should be able to program stuff. So we will do this quite often. So as I already said, we have a lot of experience with iOS applications. We have several applications out there that you can actually see. Maybe you have seen this logo at some point. This is the guide tour, and you maybe see these little objects around the city. This is in a class where you can learn a little bit about the research done in RWTH and in the city. So you find these all over the map somewhere, and if you can download the app and check it out, we have some nice tools and information about how research is done at the university. So if you see that logo, that's an application that we wrote sometimes. We have a tourist guide that is in the Center Route Charlemagne. This is the museum at the Katschhof between the Dome and the Rathaus. You can go there and you have a tourist guide. This is an application that we developed. We developed several applications for the city itself. They're not used. And on the other side, we do a lot of research using mobile devices. We do a lot of AR tracking, we do a lot of input modalities and stuff like these things, a lot of research regarding mobile interaction, how people interact with mobile devices, and how we can use new capabilities, for example, face tracking and head tracking, how this can be incorporated not for authentication, but also for interaction. For example, for people who cannot move their arms, you can use head tracking for interact with a mobile device now directly using mobile device. So today we'll talk a little bit a lot about administration things, and then I will go a little bit into the first introduction of these things. So this is a 6-credit course, and we have class times on Mondays, 12:30 to 14, and today and on Tuesdays from 10:30 to 12. We don't make any difference between lectures or labs because they're all the same. I will talk about the process in then. And the major drawback of this class is we only have 42 seats. This is a limitation, first, of the room and about our resources that we can spare. Because we will do the lectures, I don't care if I do it with 1,000 or 5 or with 40 people, but for the seminar and for the projects part, we don't have the manpower to support more than this, and we don't actually have the time. So as I said, the class is divided into 3 parts. We have the lecture, which is basically a frontal lecture where we do a lot of code examples, and we'll talk about Swift introduction and how to work with the basics of iOS. Here's a chair left in the front, and there's another chair. Here's one free, and there's one more. I can also have one more. I don't need this one here. So, and then we go into the seminar where you actually have to learn about a specific framework, and you have to actually provide an example code and present this framework to the rest of the class. And at the end, we have a project where you have to develop an application using a specific thing. So, grading, quite simple. We have 3 parts here. So we have, as I said, we have the seminar, which is 70% of the final grade. Then we have the project, which makes the most part of the grade, which is 50%. And then we have at the end an oral exam on the 6th and on the 7th of February, where it's roughly 50 minutes discussion about the topics. I will go into that in detail. So about the lecture, it's about introduction into Swift. It's about how to get to work with Xcode if you've never done that, and introduction into UI kits, so the visual side of the programming, how to interact. Tables, navigations, a little bit of web coding, which is what is there typical for iOS, and AR kit will be involved. So the basics. So we will teach you basics, and we follow this particular book. This is a book that you can download for free in the iBook store. It's from Apple. It's called Everybody Can Code. You can actually go to that website. The book is targeted for people who have no idea about programming, so it's very easy, and it's actually planned for a year, but we will do it in 5 weeks. So no worries, it's very simple. So we will skip a lot of these contents because they explain a lot how variables work and stuff like these things, and you should know this. And object-oriented programming is there explained, but we'll cover parts of these things, and you can actually go back to the book, and there are some examples there you can actually test, and we will give you links where you can actually test your skills then. So the book is very long, but as a computer scientist, you should be able to skip like 50% of the content because you should know these things already. If not, maybe this course is not the right thing for you. Just saying. Okay, seminars. We already decided on a lot of topics. We will switch it around maybe a little bit, but these are some topics that we choose. So you will give a task, for example, Swift UI. You maybe have seen that in the last presentation of Apple. This is a new way how they envision how to create some kind of applications part. And your task would be, if you get this topic, look into this, program an example, and present this example to the rest of the course. So, and therefore, we cover a lot of different topics. There will be groups of 3. So and it will be 20-minute presentations. It will be during the 18th of November until the 9th of December. And attendance during these times is mandatory because it's a seminar during that time. The lecture, I cannot force you to come, but encourage you to come. But for the seminar and for the practical part, I actually can force you to come. So make sure that you have time on these things. As I said, it will be an overview of the examples. So for example, what is Swift UI? And you should then dive into this application and basically present to the others, okay, what can I do with it? How can I start with it? And what kind of interesting features does it support? The same thing for the other things like Metal, which is the successor of OpenGL. So it's a very, very low-level graphics rendering pipeline for Metal. Some of you know Voelker? Someone heard the term Voelker? Okay, it's the follow-up basically of OpenGL, but you heard OpenGL, I hope. Yeah, OpenGL is very old, and they started to do it new, and Metal is basically the new version of this thing. And Voelker is then this thing that you find on Windows and on Linux, but they're essentially the same with some extensions. For the project topic is not fixed yet because we always have an issue in this class. If you want to program something, you need devices. We cannot give you 40 devices, so we don't have them. So and also access to Macs because you have to program on a Mac. And so we will usually start looking, okay, what devices do you already have when you enter the class? And then we decide on what kind of applications we want to write or let you write. For example, if you have a lot of devices, then we can do a lot of AR applications. If you only have access to a Mac, we have to work with a simulator on the Mac. There, AR obviously doesn't work, so we will decide on that depending on what kind of access do we have and what kind of devices we can spare to give you out. Also, groups of 3 doesn't have to be the same groups as the seminars, but we can mix it up. And what we want from you is at the end, which is at the end of the lecture, we want to have you submitting actually an app that's working. So it's not something that should be like testing and have like hundreds of bugs. It should be a workable system, not something that we want to sell directly in the App Store, but it should be a workable app so you can actually understand the process. And at the end, you have to do a final demo where you present the application. And a very important thing is code documentation, because we will go, at the end, we will go through the code and maybe we get some ideas for questions for the oral exam. So why did you program this in this particular thing? So we will actually go through that and ask the particular groups then, okay, why did you do this? Or how could this be done better? So code documentation is very important, and if you ever go to industry later on, it's a very, very important thing, because it's the worst thing that can happen. You get like 100 lines of code and you have no idea what they're named, and the variables are named A, B, C, D, and you have no idea what's going on. As I already said, then at the end it's your oral exam, and the content of the oral exam will be all the lectures here, which I give you, then all the seminars, so not particular the seminar that you will present, but all the seminars, and your projects. So we will not ask you questions about projects of the other people, but we ask you particular questions about your project that you submitted. So until you hand in your project, we will look through, we will go through the code, and then we'll find maybe some interesting questions. And we usually, over the last years, we've already found some interesting questions. So you will work as a team of 3, but you should know what your project was about. So you should not have one programming the stuff and the other one sitting around. That will be not so good in the oral exam at the end. Okay, as I said, February 6th and 7th, so we can, since it's an oral exam, we can shift this around a little bit, and since you're too many, we cannot do it in one day, but it will be like 2 days of exams, and we will figure that out on the end. So, course requirements. You should know what object-oriented programming is. I will not go into that. I will do a little bit, but not in detail. So you should know these things, but I guess you know these things. You should have an Apple developer ID, which you can just register. Otherwise, you cannot develop anything on a Mac. Not entirely true anymore, but you should design this. And if you want to later in a project use, for example, CloudKit or a specific framework, we have to invite you in our development program, and therefore you have to have an Apple ID. You can just create it for free. It's on the Apple developer side. As I already said, iOS applications can only be developed on a Mac. That's unfortunately, but that's how it is. There are some Hackintosh systems, but I will not support. We had some students over the last year who tried that out and who came to a certain level to do that, but if you have any questions there, I cannot help you with that, because so I encourage you, if you have a Mac on an iOS device, that is usually helpful, but we will not select people depending on this. It's just we will do it randomly. You should register to this course on RWTH Online. I think most of you did that. I have 120 registrations, so 3 times the size of people that we can take. But there are a lot of, and you should do it today because we will select people by the end of the week. This thing. This course in particular, we have a lot of requests from other faculties, but since we only have very limited seats and we already have a lot of things, it's just for Bachelor Computer Science, Master Computer Science, System Engineers, Media Informatics, Data Science, and TK students. Is anybody of you not part of one of these programs? Yes. What way?
Electrical engineering.
Yeah.
Is that an issue?
Yes. You can stay for the lectures and for the seminars, but you cannot participate in the groups or.
Can I join a group of 3 and make a group of 4?
Yeah, that is possible. Yes, but we cannot give you actually like. Yeah. So if you just stay here, attend the lectures, and attend the seminars, I don't mind. If it's not 100 people, then the room is full, but otherwise it's, because we have only limited time for the seminar presentations, that's basically limiting the way, and then we're focusing on the students who actually have this course in their curriculum. Sorry for that. Okay, as I already said, we have only 42 seats, and the seminars and the practical meetings are mandatory. During the practical things, we're not doing any lectures. We will have half-an-hour slots during the lecture time where we actually talk with each group individually about their project. So there's a lot less face time, but we have like intense coaching during that time. We actually talk to you with people of 3 about your application. So you only have then and half an hour where you have to come, but you should come during that time. Otherwise, not very productive. So that's something that I need to say. So if you really want to take this class, make sure you can attend. Otherwise, it will be unfair for the other people. So make sure that you want to decide on these things and check this out. Yes?
What will happen if sickness or anything?
Sickness is fine if you have the certificate, the usual rules. Like if you're sick, you're sick. I cannot do anything about. But the normal rules, if you are sick for some time, get a doctor's certificate, and it's totally fine. It's like an exam as well. But make sure, because over the last year we had people like attending the first couple of hours and then they left, and then finding new students who actually want to take the course is very difficult, because jumping in later on is very difficult, and it's a hassle for us and also for the students who came back in. So if you already know, okay, I maybe want to take that class, but I'm not sure, maybe give the slot to someone who was actually interested in this and want to pursue this for detail. Okay, as I said, registration should be done today. You should sign in and hand in the declaration of compliance until the 10th. I see already a couple of people having that. I have a set of them here, so you can sign them and hang them back. It's basically saying you're not cheating during that time. So agree that not stealing code and stuff like these things. So you should submit them until Thursday, and you should form groups until Thursday. You can also do it today. I have a couple of sheets where you can write your names and hand it in, or you can, we will all invite you to the Moodle as additional users, and you can use the discussion forum there to ask if you don't have a group yet. And you have to either do it, give me this sheet after the lecture, or send us an email with the details, because on Friday we will randomly choose 14 of these groups who actually can participate. So we're not choosing anything on any curricular support, because it's not a mandatory class for anybody, so we'll do it purely random. That's, I think, the fairest process that we have here. Okay, as I said, the sheet is here, up here. You can give it after the class. This is the information for if you do it, if you later want to decide that. Send me an email through Thursday with the subject and the content of these things. As I said, everybody who's invited, who's currently registered to Moodle, we will invite them as an additional user to Moodle. And on Friday, when we decided who will take the course, we will throw everybody out and let the rest in who got accepted. If then somebody wants to, like electrical engineer, want to stay there, just drop me an email or ask me. I can add you as an additional user then later on next week. As I said, we will provide all the slides on the videos, will be online. I hope I can upload them on the next day or on the day. So I'm currently recording this. I will put the slides not only in Moodle, but also on our website. So if you want to join or check it out, you can do it directly, and we'll upload it to YouTube. And our website, there's a link directly to the YouTube channel where you can actually see the videos. So if you don't really participate, you don't need the Moodle actually, but you can use it anyways. All right. Does anybody of you have questions about the process, formalities? No? Okay. Okay, then let's get started. So what we have here, and we'll go a little bit today about the chapter 0. So it's basically the difference, or what is important about developing applications for mobile instead of like desktop. And my first question is, if you, for example, have a mobile device here on one side, what do you think is different there when you think about development and usage of these applications? What are the main differences? Any ideas? Yes? Limited battery. Yeah, on the laptop you also have a limited battery, because, but more than that, yes?
The input, basically, how
Yeah, the input is different. Yeah, it's mostly direct touch or pen input, and the other one you have a keyboard. But if you think about like the tablet, it merges somewhere in between something. But yeah, the input is different.
Screen size.
Different interactive approach with users.
Yeah, that's interesting. I will go into that a little bit further. There's
The Windows. I mean, on the desktop we always use Windows or some kind of tiling interface, and on a phone we usually have one thing.
one. Yeah, it's limited in screen size.
Reachability problems.
What do you mean by that?
When you have a laptop, you have normally can you reach relatively easy every part of the screen.
Mhm.
Click there, and for a mobile phone with your thumb, especially when holding it in one hand, you can't reach the top left edge that good.
It's a little bit strange, but it came to that over the last 10 years that the screen size is actually now a problem. Yeah.
Making a screen size for laptop and phone, so you switch it between. And
Yeah, so you have to adapt these things, yes.
Yeah, the phone is smaller, so you can't put so much stuff on it, otherwise it will be distracting.
Yeah, and that comes into play with the input device. I mean, with the cursor, the mouse can select one pixel on the screen.
Yeah.
The finger is quite thick. You could do a button quite smaller to detect it, but to touch it, it's actually very difficult, yes.
A different amount of data inputs due to with the sensors.
Yes, yeah. There was one.
You have to design your interface dynamically that it can be shown on an iPad and.
Yeah, you have to think about different, but you have to, at some point you have to do it on a I mean, if you have like a laptop with 15-inch or 30-inch, it's also different. But yeah, I know there on mobile, it's even different there. So somebody of you said that the context is actually important. And I think that's one of the most important differences. Because getting run over by a bus using your laptop is very uncommon, but it's can happen in a mobile world. Because in a mobile world, you're not fixed in one position. You're walking around, you're sitting in a bus, you're doing it way more on different positions, and you have to think about these things. So this is a very old video, but it basically shows the exact process. So this is the woman using her phone and jumping into the fountain because she got totally distracted. And this is actually something that people that you have to think about. On a desktop environment, you don't have to think about it, because on the desktop environment, people sitting somewhere and using the laptop. On a mobile device, you have no idea at which point the user is using your device. Are they using it while they're running because they want to catch a bus? Oh, skipping to that. Or if they're sitting around at home or sitting on the couch, or if they are moving a lot because they're moving around, or if they share this thing. So you have to think about how to use your application in different environments, and you have to create an application that works actually in different environments. And these are the points that you almost all of them were mentioned by you. So the context is one of the most important things. The screen size is compact because you want to still keep it in your hands. For iPad, you could argue a 12-inch iPad is not something that you walk around with. But I mean, if you go to concerts, people take pictures with these gigantic things. But if you say mobile phone, it is limited in screen space. And you have, usually you have only one screen. So in desktop environments, you have multiple screens around. But on a mobile device, you have just this one screen. And already said, you usually have one application at a time. If you want to change an application on a desktop, you tap into a different screen, you can sort them around. On a mobile phone, you usually have just one. And you have to, and this is very, changes the concept of application environment, because you have just one system in charge and you have to switch between the system. You have to be ready for being switched around before maybe you load something and you get sent into the background and you cannot load anything. What happens if then the user starts again the application? So how to handle these applications? So you have to handle a lot of more errors that you usually don't have to deal with on a desktop environment. However, what is one application at a time, and iPadOS, you maybe have seen that, that's not entirely true anymore. Because on iPadOS, it goes more and more like a desktop computer. You can have these tiled screens and have multiple applications at a time. So iPadOS changes this concept in a way, but very focused on iPad applications, but also only limited. So you cannot freely arrange any screen somewhere. So it's still in its usage and very limited compared to if you think about a Windows machine where you can have like hundreds of windows aligned in a certain way. The other thing is on-screen help is very limited. That's actually a big difference here. On a mouse, you have, when you use the mouse, you have a hover effect. So you can move a mouse above an icon or something and you get a tooltip. That doesn't exist for touch input because touch input directly interacts with something. You could think about, okay, I'm pressing something and holding it for like a second or so and then I get like a tooltip or someone. But usually people don't tend to do that. In touch, it's basically a binary input. There's a touch and as soon as I release it, I trigger something. There's not something like a right click or there's no tooltip environment. There's something like a right click, but it's barely used. I mean, there's a reason for Apple to remove the force input from the device because nobody ever used it. Some expert users did use it, but at the end, the typical user didn't know that this exists, in a way, yeah. And this is due to direct touch or pen input. And we see more and more pen input comes into play with the iPadOS, but at the end, pen is the same thing as a touch screen. It's basically a positional cursor with additional information because you have rotation and you can have some pressure information. But at the end, it's just one content point. So to go a little bit into one of our other lectures, I want to just present this up, and this will come up eventually or often more in the projects. It's from DS1. Who of you took this class or is currently want to take this class? Okay, a couple of you. Who of you took the class? Let's ask this one first. Oh, already a couple of people. Who of you want to take this class this year? Okay. So DS1 is basically about the human-computer interaction principles, so the very low, or the human side of how people interact with systems. And in this research area came up with a couple of golden rules that you should follow, and I would just briefly want to go through them, and we will catch up on these later on again. So the first really simple rule is keep it simple. Don't overdo it. Don't mess it up. Don't do an SAP system that nobody understands. Or don't design RWTH Online the way it's currently designed. Literally nobody understands what's going on there. And I will do a lot of RWTH Online examples here because it violates basically all of them. Speak the user's language. So if you want to have an application where you want to calculate something, give it the right term and don't use some kind of weird notification that is maybe internally for you make a lot of sense, but the user have no idea what that means. For example, there's a lot of examples in the RWTH Online which doesn't make any sense for us. It's designed for Austrian audiences, but these words usually don't exist in our term because we bought RWTH Online from an Austrian company and we have the same terms. Be consistent and predictable. So if, for example, you create an interface which has a table and you click on one thing and get another table, don't change the table. Make it the same table. Make it doesn't like reverse the scrolling or something like that. Make sure that people can anticipate what's going on. Because what happens if people are confused, they stop using the app and just download another one, and you're not selling any apps. Because that's something that is very brutal on the mobile environment, that the App Store has hundreds and thousands of different apps, and for every task you want to do, there are at least 20 apps. And if your interface is confusing or people have to load something or have to log in or something, they just delete your app and take another one and try it out. Maybe eventually come back because yours is the one that the least sucks, but that's unfortunately how it is. But that's the way on a mobile environment because there are so many apps for everything there out there. You have to have an app that is easily understandable and can use. Provide feedback. So don't say, okay, you have to download something and I'm not telling you anything. Tell the system, okay, I'm currently loading something or the GPS information is currently loading or whatever. But don't make it like, I'm showing the little spinning thing without any information or some. Again, people will stop using your app, download another one. Because on mobile environment, you also have to take care about, that's actually something that we missed, connection. Connection is a big problem. On a laptop, you just have Wi-Fi or you don't have Wi-Fi. There's not a lot of differences. Sometimes you have bad Wi-Fi, but on mobile devices, you can have switch between Edge, 3G, 5G maybe, LTE, whatever out there. You can lose your connection when you're in the bus and you currently in IDROM while the bus is here, but the bus turns the corner and loses the network connection and you're basically stuck. because the system is too stupid to change to LTE or something, or your plan does not support LTE. So all of these things could happen there. And there you have to like provide feedback saying, okay, I'm sorry, I cannot download this because the Wi-Fi connection is lost or something. Memorize memory load. So don't ask the users, remember all these things on the next screen and then they have to put in something. Or give them hints when they load something. All these simple apps have just basically the calculator is a good example. It's just a calculator that we all know. It doesn't have to require login or anything or any information that you don't need to know. Avoid errors. Yeah, that's easy to say, but not always solvable. But help to recover. Tell the people, no, this is error number 55. Tell them actually what happens. Tell them, say, okay, I'm sorry, I lost their network connection. Please log in or enable network connection, and tell them how they can recover from this state, that they're not lost, saying, what is error number 50? Okay, I'm lost. Or offer undo. For example, this is an interesting challenge for mobile devices, how to do undo, because there is no right click. You could shake or whatever, throw the device in your hand or do it with your nose, whatever. There are so many different concepts, but a lot of times it's hidden. How does the user know you have to shake your device to undo? Or how does the user use you have to do 3-finger swipe to the right edge of the corner? So there is no help. Or throw your phone away to undo, whatever, use the gyro or something. It's all out there. There are all applications that use these things, but these features are hidden. Nobody knows these things because the device does not tell you that they need to know. So if you implement gestures, be careful about these things because people tend to forget these things. Include help or documentation. Always have something like, here's some feedback. Even for the simplest application out there, there are people who will get confused and getting lost in application. Think about elderly people who now start to have mobile devices on a common basis. And for these people, you have to design an application, and if people are actually afraid of technology, because a lot of studies show that some people who never use technology are actually afraid of touching the screen because they're afraid of breaking the glass or something. That exists, and it's a very large user group, and if you develop an application that is interesting for a certain use case, you have to design also the user interface for these people. Documentation, so describe what you're actually doing, provide these things. Offer shortcuts for experts. That's actually an important thing that is always overlooked. You can make the best application ever that is very, very easy to use for simple or for first-time users. But if you get an expert user, so your application, you use it like 100 times a day, they want to do shortcuts. They want to be able to skip all of these introduction things. We have keyboard shortcuts which are often used. Nobody knows why it's Control-Z. It was just defined at some point, but people are really, really fast with these shortcuts. And they're really, really fast with shortcuts in a lot of difficult applications, but it's a learning process. But if your application does not support shortcuts, but you have to go through 500 different types of tabs, people will say at some point, I don't want to use it anymore because it takes me freaking long. And they will switch to these things. So it's a hard challenge between making it easy for novice users, but also making it still usable for someone who actually uses this a lot. So maybe there are different concepts that allow you to change different modes, or you have these shortcuts where you say, okay, press 3 times here and you can do these things. And the last one, this is something that we found over the last years. Hire graphical designer. It's always a good thing. I'm not sure. A lot of computer science people are actually quite good at graphics design, but typically we are not. So if you write a real application, don't say, I can do everything yourself. I design the hardware, the software, and everything. Make sure that you use your skills in the right way, and at some point, if you want to develop applications, get someone who actually has an understanding what graphics design is. Sure, you can read up a lot, but someone who studied graphical design is probably helpful in developing like real applications that you put out there. And this is something that we learned over the last years. We also started out creating our own little graphics and found out, no, we are not that good at these things. So I want to just show you three examples that I found quite interesting, which are solve or address a lot of these points here. And the first thing is the timer, and the projector is not good, but basically the main function has, you have the tab where you can switch around, but it has 2 buttons. It has a time and 2 buttons. And that's all you need. You have to have start, stop, and lab, maybe, if you want to do this. Application doesn't have to have like a very difficult way of how to present it, but it's a very simple thing. People want to use this application for just doing a timer, nothing else. They don't want to learn something about your newest app somewhere else or whatever. They just want to know these things. And this application is probably used for a couple of seconds, then it goes in the background, and then it's back on again. The same thing is with the weather app. You could design a weather app saying, yeah, this is your location, and maybe you want to have the weather from today or tomorrow or the next 5 days or whatever. So if you go for different websites, it's just for the weather. What's the use case in this case? I woke up in the morning, it's still dark, and I want to check the weather. I'm just clicking this thing, I'm seeing the weather, okay, it's currently raining. And this information tells me, yeah, maybe it's still raining, depending what clothes I want to wear. That's all you need to know in this application. Sure, you can make it more complex, and people can swipe around here and move around these things, and they get more information. But I would bet you that the use case of these applications is mostly, I want to see what's the current weather outside, so can I go outside or not? Do I have to wear a jacket? So this is a very, very simple task. It supports more information, but the main task for the main users is you need just the cloudy thing and the temperature. That's the simplest version of this application. Also, this is the ASIAC app, which is okay-ish, let's say it like this. But this is the basic view, and this is also addressing the main need of the user in this particular use case. It's basically saying, okay, I'm currently somewhere in a city, I want to take a bus. The question is, where's my next bus stop? And then I can click on a bus stop, and then it tells me where to go. Sure, it has more functionality like the journey, which is broken sometimes, or the buses are broken, I don't know. But it addresses the most used question at that point in time when the user starts walking around because it starts raining, I want to take the bus. Here the information is just needed, where's the next bus stop, and if I found the bus stop, where does the bus go? Nothing more is there out there. Okay, I will go a little bit into the iOS family here, so talk a little bit about design implications of this one. So these are just 4 examples of the iOS world. The iOS world is now watches, tablets, smartphones in a large variety of different sizes and ratios. So for example, we have like this is the 11, which has 16:7 aspect ratios. The tablet has 4:3. This has almost 2:3. So if you design applications, you have to, even on the iOS world, you have to design for different aspect ratios. And you have to design applications that work on these devices differently. Because you can say, okay, here I have some screen space, I can present something, but on the watch, yeah, there's not a lot of space here. So there's not something I can show a dialogue or a map with how would the bus stop application would work on the watch. Probably not with a map and a lot of small little icons which I have to select. It's not working. And on the iPad, maybe it looks also different and maybe shows you more information. So you have to, even on this level, you have to design these things. And for a lot of long years, Apple actually had, the WatchOS was always different, but the other 3 were very similar. There was no difference in developing applications for the iPad than for the for the iPhone. It was just a different size. You could detect that size and adapt to that particular size, but it essentially was the same. Now they're changing it. Now they said, okay, it's iPadOS because they basically want to push that to replace your typical desktop computer with an iPad. That's, I think, the overall goal, and that's where they're heading. And I think it's for standard users, it's fine. Developing code on this thing is probably not the best idea, but maybe we'll get there at some point. But still, if you want to have an application that runs on all of your devices, you have to think about for each device, what's the use case, what can I present there, and what are the limitations. For example, the limitations on the watch is battery power, way stronger than on the other devices. If you have an application that uses, like, for example, GPS full time, it will drain your battery like hell. Also difference here. When you use, for example, ARKit on a mobile phone, yeah, it gets really, really hot and it's really, really fast empty. On the iPad, it's a different story because the battery is way bigger and you can think about different environments. But also handling a large device like in your hand and watching around, it's maybe more difficult to use than on the phone, which is like similar. So the iOS idea is basically one app for one task. So it's very app-centric. So basically you have, for everything you have an app. There's an app for everything, basically. And what you do as a developer, you develop one or multiple apps, but they're usually very separated from each other. Now they have like a files app where you can actually have like a file storage environment just across multiple devices. It's possible, but it's very limited. You will not have this application that runs on your desktop computer where you can hack in using a terminal to access everything. That's impossible on Apple. They use a lot of sandboxing. And to get the rights to use particular areas of your screen, for example, you have to have a certificate to use the camera on your phone as an application. And you have to ask the user, am I allowed to use your camera on the phone? So it's a very protective and very sandboxed in a way. And connecting information between multiple apps, there are some these deep dives where you can switch between apps in a way, and there's these extensions where we talk about this. But usually the typical application is just alone, doesn't have any connection to the rest of the environment. It can load an URL and switch back to Safari, or create an email and switch back to mail. But communication between multiple apps is maybe not the best way. For some applications it makes sense, but not for all of them. Yeah, and as I already said, one app per one task, and not creating like this is my 999 tools app for solving 300 different kinds of tools. It's more like people have the idea, okay, this is my app, I solve this for the weather app. This shows me the weather app. Then I have a calculator app. Then I have a bus app. Then I have an app for whatever. But don't try to crunch in as much features as you can in your app. Make clear, okay, this is the app for this particular use case, and it does it really right. And not saying, okay, I'm doing 20 things, and none of them really in a good way. Yeah. The data is usually stored also in this particular sandbox. So you can have connection points to the file app that you can say I want to save a file in the iCloud or something, and I can access that on my Mac or on my other application. But usually if you have like storing information on your apps, it is usually stored in this particular sandbox, and none other can access this information. So this is also something very different from the environment. So designing UI. First thing, it's also going in the direction of keeping it simple. Make it obvious how to use your application. So don't hide your timer behind, okay, let's have to go to this view, and then you have to go to this view, and then you have to log in because we want to have your data information. Just provide the information on that. So it's also something, sure, it's good to have user information, but maybe you don't need that for a calculator application. Nobody has to log in for a calculator application. Sort information from top to bottom. That's because that's how people read. They usually start from the top, like a sheet of paper, top left corner, going to the right and left. If you develop applications for Arabic environment, you maybe do it in the other way around, but essentially people design these things in a way. Use visual aids to solve that. So the typical graphical design applications. So how do you steer users' point of view to a particular use case? Use alignment, hierarchy, groups, all the stuff, Gestalt laws. You will either have heard that in DS1 or you maybe will, so we'll talk about this. So use graphical environments to guide the user around and not distract them by flashing everything around. The typical HTML blink environment is maybe not the best thing to do. Or if you just, for particular, maybe there's an application at some point where people actually want to have click a button, but usually not the best idea. One thing also is don't be afraid of using multiple views. That's a typical common mistake that a lot of people do, is basically saying I'm crunching everything in this particular view. I'm letting user select something, and then I change the view entirely, and then I will put something in there. And I just want to give you a simple example here, the Notes app. The Notes app is a very simple app that just allows you to take notes. So what happens is this is the first view. You create the one, and then you create and you go back to the views. So a lot of applications are basically a lot of stacks of different views. And that's totally fine because you want to use the screen space as easy as it is. And have these transitions make clear, okay, now I'm at the point where I have the overviews of my notes, and now I'm at the point where I create these notes or write text in these particular notes. And this helps a lot of people to understand, okay, I'm currently in that mode, and I want to go back. I use the back button, and then I'm switching back to screens. So a lot of applications that you will develop are consisting not of one large window with like 5 different views or something. It's basically a lot of views stacked again. So you have basically these different things. Yeah, that's something that you should do on the desktop environment as well. Text should be readable. It should be quite large, because if you think about it, if you walk around with your WiSe, it shakes a lot. Reading small text in font size 8, maybe not the best idea. So you should do it a little bit larger, because the distance is also quite longer. Yeah, avoid inconsistent appearances, so don't change the entire style of your applications in every view, because then people are confused and they don't have the sense, okay, which application is currently on, because there's no indication. There's just this app on there. There's no app icon like on the desktop. Okay, this app is currently open. These 5 apps are also open. It does not exist. It's just one view, and this is the app in charge. And if you change the appearance in every view, yeah, people get lost and find out, okay, this is not the app I want to use. I quit it. Provide fingertip size. This is a common mistake if people transfer applications from desktop environments to mobile. Your finger is quite fat. It's actually called the fat finger problem, because the finger is about 1 × 1 centimeter for normal touch input, and you should have targets. The smallest iOS targets are out there that are designed as 8 by 8 millimeters. Because what happens is, if you create a touch point, it's not as obvious as we'll use this here, as on a desktop. So on the desktop, you have your mouse cursor like this, and this is the point that you touch. That's easy. Or this is the click point. This is just 1 pixel. And you can make then a hit test in your environment and say, okay, which object is below this particular pixel? However, on a touch screen, you have, this is your finger. It's a capacitive sensor, so it senses this ellipsis. So what's your touch point there? Is it this point in the center? Is it this point here? Is it something like this? Or is it something on the side? For example, if you think about it, if you interact with your thumb, you don't touch, your thumb is not directly touched like this on the screen. It's more like a little bit shifted to the side. And most people use the device with the thumb. So it's basically something, maybe something here in this area. So make the target big enough that people are actually capable of hitting these things. And there are actually research about this showing, okay, what does a user actually mean when they touch a certain location? And it is not the obvious thing that you could say, okay, it's the center of this ellipse. So this is the center, and this is my touch point. This is not true. This is what the system thinks is true, because it's mathematically correct. But people think it's a different point. People think it's actually a different point, way more higher on your thumb. So it changes things. And that's actually what iOS does. If you create a touch point and you don't get the ellipse, but the system takes the ellipse, and then it adds in the y dimension 10 additional points. So it's actually in the upper part of your ellipses, because they showed, or they found out, that the center of the ellipse is actually a very bad indicator for what the people are touching, especially for the thumb, because the thumb touch point is quite large. And if you have a very, very tiny target, which you occlude with your fingers, so you actually don't know if you actually hit it, or if you have another target in there. So just create large objects or touch, like in this case. Minimize text input. Maybe you have seen this. Last week there was a study from, I think, Chicago, where people actually showed that a large people are getting faster using touchscreen typing than keyboard typing. Did you see that? Probably not. So there's always this myth of saying, okay, typing on a touchscreen is slow. That's explainable because you don't have the haptic feedback. You have to look at these things. But over the last year, people get very, very fast. And if you've ever seen people fast typing on a device and they're actually like championships on something, that's crazy. They get really, 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 really fast. But still, the typical user has a lot of hard time to create text on a piece of glass, essentially. Because you don't have the feedback, you always have to look for the button. You don't know, when I type a key on my keyboard, I know, okay, I'm feeling the keyboard, okay, this is the delete button, I can press it. I don't have to look at it. I just have to roughly aim for it. But on a touchscreen, you always have to make sure, okay, am I pressing this particular button? So text input is typically an issue. And in most cases, you have maybe one thumb or two thumbs. Compare that to a desktop computer, you have 10 fingers. You're way faster than these things. So try to minimize text input if it's not needed. Also, said it a little bit, smartphones are usually only used with one hand. Because the typical use case is I'm standing in a bus, I'm holding like a pillow that I don't get wet, or I have a coffee in my hand and I'm interacting with my phone. Yeah, sure, I can put it away and use the second finger as thing, but this is not the typical use case. The typical use case is basically the thumb. And this is where the reachability problems come in, because at some point I can not reach most parts of the screen. So you have to think about these things. Sure, you can have 10, these devices can track up to 12 fingers, I guess, at the same time, but it's like, yeah, how would that work? And so if you create an application that does not need multi-touch interaction, don't do it. Because, yeah, you as a technically skilled person probably tries that out, but a lot of people don't try that out. So I'm actually shown studies that a lot of people who use their mobile phones in the first years never know that they can detect more than one touch point. Maybe two for rotating and scaling, but usually less than that. Also, if you create this follow the Apple design guidelines, they have an Apple design guideline that tells you which multi-touch interaction should be used for what to be consistent. And if you use complex gestures, for example, if you want to have an application where people have to write gestures, like write a 4, tell them. They will never figure that out on their own. And here's just a few examples of these things. So this is the typical Apple use case, and this is true for every touchscreen, basically. We have the simple tap, which is comparison to mouse input. It's basically interaction on release. On a mouse, you usually click and then release it very fast, but on a touchscreen, usually you can click, hold it for a while or something, but it triggers an action before you release. The drag is obviously, flick is something that is limited, that's not very often used because it's kind of, for games, you see that a lot, but it's not very accurate because you cannot really control the direction. The swipe is a commonly used interaction. Double tap, sometimes, it's very often used in mouse, but on touch, yeah. Then the pinch open, pinch close, and touch hold. So these are the common gestures. If you go beyond that, you have to incorporate that in your design and understand, okay, maybe nobody or a lot of people will have problems to figure it out. So designing, you already talked a little bit about this. You have a lot of different aspect ratios and orientations. So these are just a few examples. Sure, we are currently in a state where Apple only provides one example, but you should support legacy devices. For example, the iPhone 8 has a different aspect ratio than the iPhone 10, and if at some point they will release maybe a new version of this budget phone, it will have a different aspect ratio. So aspect ratios are designed. And also you have for each device, you have two aspect ratios. You have the landscape and the portrait mode. So people can shift the device, and then you have to adapt your user interface, because if you designed an application that works very well, where you show some content up here, then the middle content here, and some content here, if you flip it to the side, it doesn't work anymore, because how would you adapt that? And you have to react on your application. So you have to design your application in the use case. What happens if somebody flips the phone? And maybe in some applications doesn't make a lot of sense. You see that in a lot of games where they actually flip the phone. But maybe in another application for mail, when you have a sidebar or something, they will switch it on. And also, again, for the iPad thing. And just want to give you a short example what they did. So this is the Apple Mail application on the Apple device, on the MacBook. So we have these folders here. This is my inbox here at some point. This is my emails, and here I have this particular email. So it's one window with 3 tabs, basically, with 3 hierarchies. This is the same way how it looks on iOS. You basically you don't have this overview side because you don't have any space for that. You have these limited saying, okay, this is my mails. I even didn't include the first one because it's another layer. So you have to have these different layers and how to deal with these layers on a very tiny device. And you can see here, these are screen spaces. On iPad, it looks different because the screen size is bigger, and you can actually work with like maybe 2 of them, but still not 3. Maybe with a 12-inch iPad, you can think about 3. But then you have the problem of input size to output size. It could be difficult. And here, this is the portrait mode where you skip around and you actually have this overlap. So on the iPad, you have to design for multiple of these things. So these are some design recommendations. And so another thing is important. The first impression that you give with your app is basically when somebody downloads it and they want to start it. And the worst thing you can do is saying, okay, yeah, it takes 5 minutes. Maybe it could take 5 minutes because it is an awesome app who loads something very, very important, and it takes very long because the network connection is long. But you should try to keep people busy and keep people interested in this thing. And so you should create an application that doesn't load everything at the same time. You can do it time to time. On a desktop environment, it doesn't make a lot of difference. For example, if you ever load Photoshop on your application, it takes 5 minutes at some point if your device is not the newest one. And on a desktop, nobody really cares because they're sitting in front of it and waiting for this. In a mobile environment, they need to know where the bus is coming. And if the bus is coming in 2 minutes and the application takes 5 minutes to load, yeah, maybe not. So the first thing, there are a lot of tools what you can do. For example, the stock application from Apple itself does it in a way. What it does, it basically shows you at a loading screen, it doesn't show the content, but it shows a screenshot of the content. So that it fakes somehow, okay, I'm currently loading this thing. The stock information is not there, but this is I'm currently loading that. And you can get that very interesting and load multiple of these screenshots, because screenshots are very easy, but the content could be difficult. But you create some kind of sense, okay, something is happening, it will come, and you have to deal with that for example, someone is just using Edge at some point, it will take forever to load these information. And this is also important, restore the state of the user when they come back. Could happen that the application is stopped for some reason because you switch to another one, and you have to be capable of like going back to the state where you want. If you have a more complex app where you have a lot of different navigation views, nobody wants to go back, start from the beginning before when they come back for like a fraction of a second. Delay login requirements. It's about text inputs. Nobody wants to log in every time, so make it only when you really, really need it, or use other devices. This is device orientation. Don't load it in the landscape mode while you're holding a portrait and stuff like these things. This is important. And also you have to think about stop in a different way, because stop works very, very different. It's way more often used. So typically you don't have a quit button in the application. So there is no X in one of the corners that tells you, okay, now the application is closed. There are a lot of ways how an application can be closed. There could be that an incoming call is saying, okay, I'm going to the front, and the device says, okay, call is incoming, go to the background, without any hesitation. You could have a user input swiping from a button or pressing the home button to go back. So you always have to be prepared to let your application die or go into the background. And then you have to think, okay, what's going on? Am I currently loading something? And in the background, maybe I'm not allowed to load anything, because in the background you have very less resources available at your time. For example, the graphic card is taken away from your application, and if you have just created a nice game application, you have to save the state of that game application somewhere without blocking your graphic card, because you don't know what the user is currently doing. You're just in background mode. store information when it's closed. So be ready to save the data, so auto-save applications without quitting. Nobody wants to say, I got an incoming call and the application that I was just having open, I really want to show you want to save this. So just do it. And again, background thread, usually we'll talk about this. You have very limited resources to use that. And Apple actually taking a lot of the resources away over time. So if your application, for example, you have a game open, you play it, and then you put it in the background because you come an incoming call, and you talk for an hour, you can imagine if the game has fully accessible features, your phone will be empty by that time when you're done with the call. So make sure that these things are available. So they're basically, if you think about applications, there are 3 different styles, graph styles. It's called productive, utility, and immersive. So you can categorize basically your applications in one of these 3. And these are 3 examples. So for example, productive could be photos, where you have like these applications where you can actually do something, or edit these photos, look at them. Then you have utility, with this just very small applications with one particular task. And then you have these immersive applications which change UI and stuff. We'll briefly go through all of them. Productive applications, as I said, could be photos, could be Word, could be like notes and stuff, where you often organize data hierarchically. So you have a lot of views attached in a different variety, where you can organize them to contacts, work with lists. For example, shopping lists is usually like a productive application. If you think about photos, contacts, reminders, and these things where you actually create content or work with this. Utility is a very small, as I said, and it basically allows you to show you information or really give you small accessible. And these applications are usually used very, very short period of time. For the weather app, open the weather app, it's 13 degrees out there, close it again. So a couple of seconds. Or for the stocks app, for example, I want to check my stocks right now only for a fraction of a second. So I have to address these details and make it sure. And I don't, for example, in comparison to the productive one, in a utility app, I don't want to go through a large hierarchy of different views because I just want to have very short information. I don't care about these details. Maybe it could be hidden somewhere for people who are interested, but the first information should be very clear at the beginning. Here are some examples, the weather app, the stock app, and this is actually a very interesting app for the iPad. I'm not sure if it still exists. It's an elements app for chemists, where it shows you basically information about the different elements in there. So it's very simple, and you can basically just click on the element and get all of these details, which could be very useful for people who are interested in these use cases. But it does not provide a lot of additional information, and it's a very simple hierarchy. So you just select your element, and that's it. Then we have immersive applications, so full screen, very rich, and usually very custom-made user interfaces. So they're designed to take you in, and they are usually very different from the rest of the device because every application developer creates their own immersive application. And one of this example is Living Earth. So you have like this Living Earth concept, and this is one of the early examples. This is where the time where I was still this fat button environment. They have this carpenter thing, and this is like you get the immersive feeling that you have actually this device in your hand. And the largest group of these applications are actually games. Games are usually very immersive apps, and they don't use any existing GUI elements. They're all custom-made. So, for example, in Tiny Wings, you have you don't have any interface. There is just a play button, and then you have to shake your phone or tap the phone. Also in Super Mario Run, there's no button that tells you, okay, press to run or to jump. It's very simple, and it doesn't have any information that is included in the game. And this is a demo that Apple presented. It's an AR application. So it's very, very different. It provides you details, okay, I can use the AR application, this little robot here, and work with it. But it does not follow any principles that the iOS provides you. It doesn't use any list. It doesn't use any particular buttons. So it's very custom-made in a way. So these are the different types, and this is the first introduction into design of applications. So with this, I want to sum up today and give you some time to figure out the groups. So we talked about today a little bit about desktop and mobile And mobile applications, the hardware restrictions, keep the hardware restrictions, battery, screen size in mind, but also keep the context in mind, in which context it's mostly used that your application will be used. And then the application styles, where you, at some point, it helps you, what's your goal of my application? Where do I want to go? Do I want to create immersive application? Doesn't make sense in this case. Maybe a weather app is not the best immersive application, it's more utility. But also, it helps you to think in your category and understand what your users actually want. So with this, further reading guidelines, if you're interested in these things, there are the iOS human interface guidelines, which are detailed user interface guidelines from Apple. So they tell you, okay, how to arrange buttons, how many buttons should be displayed on these things. It's quite nice to read. There's also this Apple Everybody Can Code website, where also the link to the book is that we use, or this ebook that we take parts of this. But it also gives you a little introduction. It is actually addressed also for children, so skip the first parts. But it goes then directly into the programming environment. It also provides you a link to the Swift book. There's an ebook that actually explains the whole Swift language on a couple of hundreds of pages. So it's a very nice thing if you want to look something up, for example, how particular things work in Swift. This is actually a good use case. So what's next? Yeah, register today, because I will invite you, all of them, today to the Moodle. Form your groups and notify us, so you can do it now. Here are the sheets, or you can write me an email if you don't find a group. And we will notify you on Friday. So everybody who got the course will be invited to the Moodle officially then, and then we will send a Moodle information. Okay, congrats, you got the seat. As I said, it's purely random. We will use random.org and select numbers in there, because there's no way that we can select them in any useful way. That's it. For those who get the seat in the class, the next lecture will be next Monday, where we talk about the seminars, where we actually distribute the topics to each group, and then we will start right on going into Swift, and I will talk a lot about how Swift works and what we can do with it. Okay, I will be here. I will hand out these sheets and the declaration of compliance. If you have any questions, I'm still here.
This content was provided by RWTH, Aachen University.